Hello everyone, myself Shubham Sharma. In the current video, we will be discussing about how to interpret the outcomes of a network meta-analysis. This is an extension of my previous video in which we conducted a network meta-analysis in RStudio using NetMetaBean package. Over there, we analyzed hospitalization outcome for different intervention, and I requested you to do the similar analysis for adverse event outcomes which was reported in that data set. I hope you got some time and might have done the analysis. If not, no issue. We will be discussing the outcomes. Following that, we will be going back to the RStudio and rerun the codes. So what is the crux of an NMA? Suppose there is a researcher who wants to determine the effects of a drug A compared to that of a drug C. But in a real case scenario, there is no such RCTs available which can directly compare A versus C. But there are two studies. Study one, which is comparing A versus B and is providing an effect size of change in hemoglobin with a variance of 1.9. Similarly, there is another study comparing C versus B, providing an effect size of change in hemoglobin and a variance of 1.1. Well, through this network meta-analysis, we can actually indirectly compare and determine the effect size of A versus C. In anime, we consider this individual treatment as nodes and the effect size or as edges. As you can see in the study comparing A versus B, the edges are solid lines, which means that the A versus B is having a direct comparison. A versus C has been compared as a difference between the effect size of A versus B study, that of effect size of C versus B study. Whereas the variance is actually the sum of individual study variance, that is 1.9 plus 1.1, which comes out to be 3.0. Well, are we ready to conduct anime? But before that, we need to understand how to deal with transitivity or consistency. Well, transitivity actually means how and to which extent your two studies are comparable to each other. For example, if your first study, that is A versus B, and your second study C versus B are having different population size. One is reporting outcomes in comparatively younger population, whereas the other study is reporting outcomes for an older population. So you cannot compare those two treatments because the transitivity assumptions has been broken. Similarly, if the dosage forms are different or the dosage strength are different, even in that case the transitivity is not been taken care of. Now, how to check transitivity or inconsistency? There are a few methods like heat plots using fixed or random effect model or through net split methods. In this, we will be discussing about heat plots and fixed or random effect model. The random effect model or fixed effect model description has been provided by me in the understanding of meta-analysis video, but over here I will give you a brief. In this fixed or common effect model, we consider that that the treatments or the studies are very comparable to each other. Whereas in random effect model, we do not consider these assumptions. We consider that the the studies are not so similar to each other. In the heat plot, we use graphical method to understand whether the studies are consistent to each other or what is the level of inconsistency between the study. Now let's dig into understanding the outcomes of the study. In the first section, as we can see that it's giving a description of what are the number of studies in the trial, in the data set, number of pair comparison, total number of observation, number of treatment, and number of designs. Number of designs actually represents the different treatment comparison group provided in the data set. As we have used a common effect model, which is also known as fixed effect model, so it has been reported over here. Now for the treatment estimate, we use odds ratio. Why? Because our outcome is a dichotomous outcome and we didn't use standard mean or standard mean difference because our outcome is not a continuous outcome. For comparison, I'm right now comparing all other treatments compared to that of placebo. So for placebo, there will not be any outcome, and other treatments outcome will be reported as comparison to the placebo. For example, let us take artesunate and halofantrine. Artesunate is having 9.57 times higher odds of hospitalization compared to that of a placebo, which is insignificant because p-value is greater than 0.05. Whereas halofantrine is having 85% higher odds of hospitalization when compared to that of placebo, which is also insignificant, as we can see from this p-value, which is greater than 0.05. Let us take one example of artemisinin. Artemisinin is having 42% lesser odds of hospitalization than compared of placebo, but it is also non-significant. Now let us check the heterogeneity of the study. We can check heterogeneity through tau square and through I square. Now tau square value ranges from 0 2 plus infinity. Lesser the value, lesser the heterogeneity. Similarly, I square value ranges from 0 to 1. It's 35.4, it is moderate heterogeneous, but it is inconsistent, as we can see from this p-value. Now let us try to understand how to interpret the league table. So this league table is actually representing the odds of hospitalization. Let us take two treatment. Let me change the color. Let's take a different color. Let us try to understand how odds of hospitalization is for chloroquine and then for doxycycline. Let us compare it with quinine and then with clindamycin. So chloroquine, we need to explain this box and this box, and for quinine we need to explain this box and this box. So the interpretation goes like this. The odds of hospitalization in patients taking clindamycin is 5.4 times higher odds when compared to that of chloroquine, which is insignificant. Similarly, the odds of hospitalization in patients receiving quinine is 30 percentage lesser than compared to that of chloroquine, which is insignificant. Similarly, for clindamycin compared to that of doxycycline, the odds of hospitalization is 3.95 times higher, which is insignificant. Similarly, for quinine compared to that of doxycycline, the rate of hospitalization in quinine patient consuming quinine is 49 times lesser than compared to that of doxycycline. Means the comparison is going through column towards the row. So this is how a league table is being analyzed. Now you can see there are different color coding provided over here. There is few light green and dark green. So you can understand that this dark green actually reports a significant credible interval. Similarly, this light greens also represent a significant credible interval. So I can say that this doxycycline is having 17.09 times higher odds of being hospitalized compared to that of artesunate, which is significant. Now let us try to understand SUCRA and network graph. Well, what is SUCRA? SUCRA is surface and cumulative ranking curve. It is helpful in ranking the intervention. I've used p-score to report the SUCRA. P-score ranges from 0 to 1. Near the value to the 1, better the treatment is. So over here, we can say that clindamycin is having lesser hospitalization. Means the patients consuming clindamycin is having lesser hospitalization compared to that of artesunate. The network plot actually reports how the various interventions are in your data set, how they are connected to each other. For example, in this network plot, we can see that there is only one study which is reporting comparison of chloroquine versus quinine. Similarly, there is only one study reporting artemisinin versus placebo. So this is a graphical representation of how your uh, interventions are provided in your data set. We can also change the width of these edges. We can increase the means we can code in R which will help us to increase the width of the wedges of these edges, which means greater the width, more number of studies are there, and if smaller the width of these edges, lesser number of studies are there comparing the two treatment. As you can see that in this heat plot, the studies are not compared to each other, whereas the interventions are compared to each other. So there are two sections you can see in this figure. One is the small or big gray boxes which are provided, and then there is certain color coding ranging from dark yellow to something like light blue. Now, what does this boxes signify? This boxes actually signifies how important is the treatment comparison in reporting the estimate of another treatment comparison. Now, if the size of the boxes is bigger, direct evidences has been used and the comparison is more important compared to that of box of smaller size. Now what does this color coding signifies? The color coding over here, this is dark yellow, signifies that there is inconsistency between the study. Darker the color of this yellow, higher the inconsistency. As you can see, only two boxes are reporting dark yellow color, whereas all the other boxes are either white or light yellow or blue in color. So we can say that the inconsistency in these studies is not that high. We used common effect method to run this model. So we can again see through random effect model whether there is any change in this heat plot or not. Now, what are the limitations of NMR? You would have seen that there are lots of things which comes into play when we plan to conduct a network meta-analysis, which signifies that the procedure is very complex. Similarly, it's resource consuming because we need large number of studies or is compared to that of standard meta-analysis in conducting a network meta-analysis. The third and the foremost important thing is taking care of transitivity and consistency in the study. Because if these two parameters are not been taken care of, the outcome of your network analysis doesn't hold any ground. So let us go to the R Studio. Okay, let us check the data set. Over here we had 10 studies. This is the intervention, the sample size, the comparator, the sample size. We did run the analysis previously for this hospitalization outcome. I asked you to run the similar analysis for adverse event if you were not able to do it earlier. Now you can rerun the analysis and even can check and understand and interpret the outcomes. I've already got this data set into the RStudio. So if you want to check how to get the data set into R, you can and install the NetMeta Bean package. You can refer to the previous video. The package is NetMeta, and I'm using NetMeta Bean as the outcomes are in the binary format. So the data is network because I've created the data set in the name of a network. Now, what is the treatment one? It is the intervention. Event one is hospitalization. And sample size is intervention sample size. Treatment two is net is a comparator. Event two is hospitalization comparator, and it is the sample size which is comparator sample size. The stud lab is study. Stud lab means study label. We are using odds ratio fixed equal to true, which is actually, a fixed or common effect model, I've kept it as true, random is false, reference group I'm considering is placebo, check multi-arm true if I'm having more than two arms. Well, our study doesn't have more than two arms, but it's good to check multi-arm status. Separate the treatment using versus and the method is inverse. So this is the same outcome which we discussed in the presentation section. Preparing the league table. There are two methods of preparing league table. First is through this method, which is a very complex to convert this into matrix form or in a table form, or you can either use this. It will provide a figure which we actually discussed in our presentation. The screen size is not that good enough to accommodate the figure, but this is what we discussed in our presentation. Now let's go with the SUCRA. Small value desirable. I've used the p-score method. Does it provide the SUCRA? Yeah, it provided it. Now net graph. Reduce the size. Now in the net graph, what we are using NMA hospitalization, number of studies equal to true, plastic equal to T true, and thickness equal to number of studies. Fine. Now what do I want to write in the heading? I've written network plot for hospitalization outcomes. So after I run the code, this is what is provided over here. It is similar what we discussed earlier. Now let us go to the heat plot. As you can see, I'm using random equal to false. So this is the plot. Over here it's a bit clear. So you can see that the dark yellow color are only two studies, whereas most of the studies are in either light yellow or light blue. So this is how you can conduct a network meta-analysis. Similarly, you can try to rerun the code used for this adverse event. So this is the description of the outcomes of network meta-analysis using net meta package, and I hope you will be running the network meta-analysis for the adverse event, and I will be happy to have your queries if you have any for this network meta-analysis. Thank you. Have a nice day.